Hi everyone, this is Mr. Ahlers. Sorry I'm not at school today. I'm really sick. But here's the PDN, just for you all. What are the roots of the quadratic function? That means we want to factor. So if you factor, you would get x plus 3 squared, because it's a perfect square trinomial. And you can set x plus 3 equal to 0, and you get x equals negative 3. Because it's a perfect square trinomial, you only have one answer. For the second one, that's a difference of squares. So that factors to x minus 3, x plus 3. Set each of those equal to 0. You get x equals 3 and x equals negative 3. And the last one, when you factor it, you can't, because it's not a difference of squares. So what I do is x squared equals x squared plus 9 equals 0. Subtract 9, you get x squared equals negative 9. And when we take the square root, we end up getting a negative 9, which you all remember is going to be equal to, the square root of 9 is 3, and the square root of negative 1 is equal to I. So the answer is 3I plus or minus 3I. Moving on to number 2. Your solutions from problem 1, write each function in factored form, which I did. Squared, and then this one's x minus 3, x plus 3, and then c. I would write it as, but these are our factors, so it's going to be x plus 3i and x minus 3i. So remember, you just use this portion, and then you write the opposite. For portion c, are rational numbers a closed set under multiplication and addition? In other words, is a rational number times a rational number always a rational number? What about rational numbers plus a rational number? And the answer is going to be yes. If you pick a rational number, for instance, like 3 over 4, and you times it by 2 over, I don't know, let's live a little, we'll say 7, we get 6 over 28, and that is still going to be a rational number. If you add two rational numbers, for instance, 1/2 plus 3 over 2, those aren't really like that annoying of rational numbers. Let's pick like 5/7 plus 3/7. If we add those, we end up getting 8/7, which is still a rational number, and no matter what, you'll get a rational number. The last one, what is the area, or the second to last one, what is the area and the perimeter to the triangle? Right, give both exact and decimal approximations. So the area is going to be nice. We'll do 1/8 times root 3 over 8 all over 2. So that's root 3 over 64 over 2, which I think I told you that if you have a fraction in a fraction and it's division, you can keep the first one. So we'll keep this. We'll change it from division to multiplication, and then we flip the bottom. And I put that over 1, so it's just 1 over 2, which then turns into root 3 over 128. Units squared is the area. Type that into your calculator, you'll get the approximate, and I guess I'll use Desmos. Root 3 divided by 128, which is 0.0135 units squared. The area is actually pretty nice, because luckily they gave us all the common denominator, so the perimeter is equal to root 3 over 8 plus 2 over root 8 plus 1 over 8. Sorry, it's 2 over 8. So then I have 3 plus root 3 all over 8. And remember, you can't really do anything about that, so you just leave it like that. I think you guys all said that I can just do that. So now I have 3 plus root 3 all divided by 8, which is like, that's pretty small. Much smaller than I thought it was going to be. 0.592, I guess, units. Alright. And part B, you add a rational number to an irrational number to calculate the perimeter. Was your result irrational or irrational? It was irrational because of the square root. If you add any rational number to any irrational number, will the sum always be rational? Any rational number plus any any irrational number, will the sum always be rational? It's going to be sometimes for both. If you multiply a rational number and an irrational number, will the product be rational or irrational? It will be irrational. Well, there's a PDN for you. Here's the objective if you didn't get it. Maybe I'll see you tomorrow.